Hi guys, welcome to lecture number 6. This is our last lecture for the genetics unit. And we're going to talk about pedigrees. So pedigrees are basically a family tree that is going to indicate individuals with a specific trait. It can also be used to help determine the genotype of individuals. So your step 1 in a pedigree is to determine the inheritance patterns. So inheritance patterns, there's 2 decisions to make. Basically, you're going to determine, is it autosomal, which means that it's found on chromosomes 1 through 22, or is it going to be sex-linked, which means it's on chromosome 23. So autosomal, your clue is if males and females are equally showing the trait. So your genotypes, for instance, could be big A, big A, big A, little a, little a, little a. If it is sex-linked, there are going to be a lot more males that have it than females. And if you think about it, we talked about that, it makes sense because the males only get an X from mom and they get the Y from dad, whereas females, they've got 2 X's. So they have a chance for a dominant trait to cover up that other trait. So your genotypes in this case, I'm going to write these differently here. For males and females, so for instance, it could be X like this, it could be like this. So there's lots of different ways to show it, but XX obviously is female, XY is male. The next thing you need to do is you need to determine, is the trait dominant or is it actually a recessive trait? So here's your clues for that. A trait is dominant if it does not skip a generation. So in this case, you are going to give the shaded individual a capital letter. Can't spell today, I apologize. So here, if we were going to label these, we know that this guy is going to get a capital letter, which means that these are recessive, right? So we know that in order for this child of theirs to have 2 little a's, we've got to have heterozygous. Okay. If the trait is recessive, you're going to know because it actually skips a generation, and you are going to give the shaded individual lowercase letters. So here we know that this guy is going to be little a, oh, that looks like a capital, little a, little a. So up here, again, we know that this child over here has a capital A somewhere, but we don't know if it is 2 big A's or a big A, little a. So that tells us up here, and we know that these parents are not recessive, so they both have to be heterozygous. Okay? Also, I want to make sure that you understand when I say it skips a generation. So here, there's no affected individuals. Nothing to go off of, but then all of a sudden there's one here. So that is what we mean by skip generation, and we'll talk about that more. Okay. Then you're going to write in all the genotypes of everyone that is homozygous recessive. Basically, your little a. And you're going to use those recessive individuals to help you determine the genotype of those with the dominant trait. So those with the dominant trait are going to be a big A, little a, or a question mark, because you're not sure. You can't determine if it's big A, or big A, little a. You will never, ever write two big A's for a person on a pedigree, because you just don't know. Okay, so let's look at this example right here. And these are two separate things. So we're going to look at this one. So the first thing that we need to determine, is it autosomal or is it sex-linked? So in case you hadn't figured it out, the circles are females, the squares are male. So are there more males than females? Not really. So we're going to say that it's autosomal, because we have that even number of male and females being affected. And our next trait, determine is it dominant or recessive. So does it skip a generation? So we look here, it's not skipping a generation, so it is dominant. So what we're going to do is we're going to give the shaded individuals a capital letter. So, and remember, we will never give two capital A's, two capital letters. So go through and label all of these shaded ones as heterozygous for the trait. And a couple more to go here. Okay, so we've labeled all of those. Now we need to look at other information that we have. So we know that these individuals are going to be recessive, right? So these are little a, little a, little a, little a. Okay, so looking, you would think that we're all done, right? But here is where we messed up. Look through here and see if you can figure out where we messed up. Okay, so we know that these two, these labeled ones, we know that they are big A, little a, right? And here, because we know that this is a little a, and we've got someone here that's affected, we know that this guy is a big A, little a. But here, do we know that this person is a big A, little a, or a, big A? We don't. So, this guy, we're going to erase. He would actually be a question mark. And then again here, do we know that all of these are big A, little a's? No, we don't, because these, again, they could be homozygous dominant. So we're going to erase those. And again, we have question marks. Okay, so then this guy, again, we've got nothing, no kids to look at, nothing to determine what this guy is. So he is, or I'm sorry, she actually, is a big question mark. These, we can determine that these are little a's because they're all unaffected, so that's good. And then we've got one more guy over here, or lady rather, who we know nothing about because there's no children to compare, so she would be a big question mark. Okay, let's move on to this example over here. Okay, so pause and take a moment. Actually, let's talk about what we're going to determine first, and then we'll go through, and I'll let you take time to do this. So, first thing we need to decide, is it autosomal or sex-linked? So we're going to look at the males versus the females. So there's not a huge number of males. I know that there's only one compared to 3, but it will be a large amount of males that are affected for it to be sex-linked. So this is autosomal. Next, we need to decide, is it dominant or recessive? So we're going to figure out, does it skip a generation? So here, no. Here, it does in fact skip a generation. So we are going to say that this is recessive. So what we're going to do is we are going to label the shaded individuals in lower cases. So go through and label all of those, and then determine if you can what the others should be. And we will resume. Okay, so I went ahead and filled in the charts. So let's take a look at these. So we filled in all of these little a's, all the shaded boxes. Okay, so the first thing, let's start over here. So we know that this guy is little a, right? So we know based off of that both parents have to have a little a, so they have to be heterozygous for the traits. However, this guy here, his brother, we have no idea what he could be because he could be a big A or a big A little a. The sister, on the other hand, got married, had a child. We know that that child has the recessive trait, so that means that both parents have to have a big A little a. Over here, again, we see a parent with a little a, and we see a child that has a little a. So we know that this father has to have a big A little a. This woman gets married, and they have children. Now, we don't know what the father is, because he could be big A or big A little a. But we do know that mom only has 2 little a's to give, so all of these children have to have a big A little a since they are not affected. Okay. So let's look at some sex-linked rules. So, males, we are going to complete the males with the trait as X, A, Y. Without the trait, X, A, capital A, Y. Females with the trait are going to be X, little a, X, little a, and then X, big A, X, little a for moms of affected sons, and daughters of affected dad would be X, big A, X, little a. All other females will be a question mark, which means that they could either be heterozygous dominant or heterozygous. Oh, I did that wrong. My apologies. They could either be heterozygous or homozygous dominant. Okay, so let's look here. So our rules that we are looking at, I mean, we know it's going to be sex-linked because I just put sex-linked rules over here, right? But how did we determine that? So the first thing is, are there more males than females? And yes, all the people affected are males. So we know it's sex-linked. The next thing, does it skip a generation? And we look here, that's not skipping. But we look here, that is skipping. This is skipping. So we know that it is sex-linked and it is recessive. So, we are going to shade the individuals with lowercase letters. So here we go. Go through and we are going to mark this guy as X little a y, X little a y, and same thing for the rest of these two. Okay. So now we can determine the parents, basically. So for this one, for instance, we know that neither one of these parents have this, right? So we know that dad is X big A Y. So that means, obviously, he gets Y from dad. He gets A from mom. So that means that she is X big A, X little a. Okay? We know here that this brother has to be X capital A Y because he's not affected. We cannot really answer anything about this sister or this sister. This sister we will decide here in a moment because of the fact that she has an affected son. So, X little a y, so we know here that dad is going to be X big A Y because he's not affected, which means here mom has to have X little a X big A. So, any of the unshaded males, you can also mark, you know that those are all XA, X big A Y, all of those. So here we have an affected male and children. So we know here this guy's unaffected and this guy's unaffected. And these two together have an affected son. So that means, again, mom is X big A, X little a. And we can say that this guy is X big A, Y. And really, that's all we can determine, because the rest are unknown as to whether or not they are recessive or dominant. Okay, so let's do another one. So our first thing to look at is, are males and females equally showing the trait or no? And it looks like they are. And then the next question is dominant or recessive. Does it skip a generation? And it does not. So we are looking at autosomal dominance. So that means that we are going to use the shaded individuals and give them a capital letter. So here, big A, little a, big A, little a. Okay. So let's see what this means for everything else. So let's start here. So this person is not affected, so we know that they have to be little a, little a. And you can see a cross between them would give the big A, little a here. Again, here, little a, right? So basically all the rest of the unaffected are going to be little a, little a. Okay, let's try this one. So the first question, again, are the males and females equal? No. There are 3 males, no females. So we know that it is sex-linked. Is it dominant or recessive? Does it skip a generation? Yes. So we are looking at sex-linked recessive. So the first thing we're going to do is give the shaded individuals lower case letters. So here we know that this guy is X little a Y, X little a Y. Okay. So we can go through and we know that any of these, the males, they're all going to be that X capital A Y because they do not have the traits. Here, for instance, we can tell that mom would have to be big A, little a, in order to give son the big A there. However, we don't know what these females are. So they would be question marks. No idea. Let's look here. We know that mom, again here, would have to be X big A, little a. But again, no idea on the female. Here, same thing. Mom's got to have a little a in order for that son to get that little a. But we're not going to know about that female. And here, we can determine mom's big X, or I'm sorry, big A, little a. Okay, let's try this one. So first thing we're going to do is determine is it autosomal or sex-linked. So we're going to compare male to female. They look about equal, so we know it's autosomal. Then we needed to figure out if it's dominant or recessive. There are no skipped... Wait, are there skipped generations? Hold on 1 second. And there is, in fact, a skip generation right here. So that means that we're looking at autosomal recessive. So the first thing that we will do is give the shaded individuals lowercase letters. So we know little a, little a, little a, little a. Okay, so now that we've done that, we can go through and determine the rest of the traits. So, for instance, right here where the skip generation is, we know that we have to have a heterozygous because we have a daughter with 2 little a's. These, however, would be questions. This one we know would be heterozygous because we have 2 little a's. This one, however, would be, actually that one would not be a question. That one would be heterozygous. Okay, and you can finish that one if you would like. So, the next thing that we're going to look at, probability problems and pedigrees. So where are we going to use pedigrees at? So there's going to be some simple as well as tricky problems. So for example, what is the probability that 6 and his spouse will have another child that can roll their tongue? Okay, so this is where we are going to go through and we are going to figure out our steps. So first thing, is it autosomal or sex-linked? So we're going to look, male and female are equal, so it's autosomal. And then next question, dominant or recessive? And it looks like it does not skip a generation, so it is autosomal dominant. So we are going to go through and give the shaded individual one capital letter. Okay. So now that we have done that, we can figure out a couple of the other individuals. So for instance, we know that these kids here are getting their big A from their dad. So this unaffected, we're going to say little a, little a. We know that these are little a, little a. Little a, little a. Okay, so what is the probability? We are looking at 6. This guy right here. So, what is the probability that 6 and his spouse will have another child that can roll their tongue? Well, if you do the cross, you will see that we have 50%. So, 50% would be the answer, or 1/2. Okay, so let's look at some tricky possible problems. So you might need to multiply the probability of 2 events. So for instance, calculate the probability that the next 2 children of 6 and his spouse will have the trait. Well, we already determined that the next child has half a chance. So it would be the same thing for another child. So we're looking at 1/2 times 1/2. There would be a 25% chance. There's also the chance that you might need to factor in known information. So for instance, if 1 and 2 have a 5th child that is a tongue roller, what is the probability that he or she is heterozygous for the trait? So let's go up here and look at 5. Oh, 1 and 2, I'm sorry. 1 and 2 we know are big A, little a, both of them. So if we do that cross, so big A, big A, big A, little a, big A, little a, little a, little a. So what is the probability that they are heterozygous for the trait. So that would be 2, right? 2/4 or 1/2. So 50% chance. Okay. Example 2. So, PKU is an inherited disease caused by an autosomal recessive allele. If 2 individuals who are carriers have 2 children, what is the probability that neither child will have PKU? Give your answer as a fraction or as a decimal. So, we know it's a recessive allele, and we know that there are 2 people that are carriers, but they are not affected. So, we're going to do a simple cross. Their carriers are not affected, so they have to be heterozygous. Okay, so same thing that we just did up above. And we want to know, what is the probability that neither child will have PKU? Well, we know that there's 3 out of 4 will not have it. So there is child 1 and child 2. So you're going to take that 3/4 and you're going to multiply it for each child, which would be 9/16. Okay? Next example. And this one we're going to use a chart. And this I just want to show here, instead of labeling each individual, sometimes they do rows. So 1, 2, 3, 4, and then they give you a number. So for instance, this says row 3, parent 2, and her spouse have a second son. What is the probability he will have the genetic condition? Well, the first thing we have to do is go through and figure out, once again, is it autosomal or sex-linked? Obviously, it's sex-linked, which means, is it skipping a generation? And it does, in fact, skip generations, so it is recessive. So our shaded individuals are going to have lowercase letters. So this guy here is X lowercase a y. So what is the probability a second son will have the trait? So we have to know that mom gave a little a, so we know that she's a big A, little a. And we know that dad is a big A, Y. So we're going to do a cross. I don't like that there. Okay, so we're going to do a cross of X, capital A, Y, and X, big A, X, little a. So we are looking at so X, A, Y, and then X, little a, Y. So we have done this cross. We have a little bit more information than what we need. We are asking about a son. So we don't even need this top information. So if we look, out of the 2 possibilities, there is 1 out of 2 chances. So we're looking at 1/2, because we are not going to take into consideration the daughters, because they are only asking about the son. Okay, so next example. What is the probability that 3/2 and her spouse could have another son that would have the genetic condition. So 3, 2. Well, this is pretty simple because we already answered this, right? So that answer is right there up above. But you have to multiply the two probabilities. So your answer would actually be 1/4. Next example, what is the probability that 3, 2 and her spouse could have 2 more sons with the conditions? Well, we already know that here we've got a 1/4 chance, so 1/4 times 1/4 would be 1/16. And then here, what is the probability that A is homozygous for the trait? So the first thing that we need to do is determine is it autosomal or sex-linked. Remember I said back in the beginning, if it is sex-linked, there will be a lot of males. So we're going to say that this one is not sex-linked because there's only one male. So it is autosomal. And is it recessive or dominant? Does it skip a generation? And it does skip a generation. So we're going to say it's autosomal recessive. Remember, sex-linked will be very, very obvious. So what is the probability that A is homozygous for the trait? Well, we know since it is recessive that we are going to label it with a little a, little a. So that means that our parents have to be heterozygous. So we are looking here for this female. What is the probability that she is homozygous? So we're going to do a cross of our big A and our big A, little a. Okay, so homozygous for the trait. That would mean we've got homozygous, right? So you have to determine the trait. And we know that we're not talking about this because she's not shaded. So we're going to get rid of that. So homozygous for the trait, she would actually be 1 out of 3. Okay, make sure that you practice these pedigrees. Make sure that you understand the steps. Make sure that you remember those, and you should be good to go with the pedigrees. Thanks, guys. I will see you later.